This conference will now be recorded.
Hola chicos, solo para asegurarme, ¿me pueden escuchar la gente remota?
Sí, te escuchamos
Sí,
bien.
claro y fuerte.
Hola, bienvenidos a la presentación. Va a estar en inglés, más bien por mi comodidad, porque los que me conocen saben que soy de Polonia y yo sí hablo español, pero me va mejor sobre las cosas técnicas en inglés, entonces va a estar en inglés, pero igual si alguien tiene una pregunta o necesita que aclaro algo en español, no hay ningún problema y me avisan. Igual al final de la presentación vamos a tener tiempo para preguntas, entonces hay por ahí, o mientras la presentación también si tienen algo como urgente me pueden decir. ¿Listo?
Ok.
Okay. So, hello. So the title of the presentation is Last One Standing, Angular, React, and Vue. Just to give you more background on why I selected that topic, is because 2 or 3 months ago, I was thinking of my goals for the performance review. And I was thinking that since I was working in Gap, I was always in projects with Angular. So I just wanted to get to know React and Vue, but not just theoretically, but also just write an application using like real life application, and that I would have kind of encounter the same problems that I would encounter when developing an application for the client. So that's what I'm going to be talking about today. And this is part of the Gap Knowledge Giving event. This is the second presentation, I think, and you are welcome to join the next presentations as well. That's tomorrow and the day after that and so on. So the agenda of the presentation is that first I'll be talking about the application, the requirements, assumptions, and the solution of what the application would be. Then some observations that I had when I was developing these applications. Then in-depth analysis, so things like memory comparison and performance comparison, bundle size, and so on. And then the results part where I will just sum up everything, and then some part of the questions if you have any. So starting with the application, the idea was to write the same application in 3 different frameworks. A application that would be dynamic, but at the same time with static elements. So dynamic in a way that it reflects well the state of the application, the current state, but also with some static elements. So for example, like the left menu, that even if you scroll down, you always get the menu or the top header. So that's why dynamic, but with static elements. Interactive and usable, of course, any application, any modern application should be interactive. So I wanted an application that when you click on something, it would, toggle, for example, the menu, just something that you can kind of configure the way that you need it to work. And usable, what I mean by that is that it's an application that a user would actually use, that has some purpose, not just some testing application that doesn't do anything, but something that actually does something. Then multiple views, so using routing. I didn't want it to be the focus point of the application, but I wanted to have just multiple views, maybe 4 or 5 different views that user could go between them. Then some asynchronous data fetch. So again, to kind of simulate the real life application, of course, the data normally comes from the server, so that's what I wanted to have. Of course, I didn't want to bother with writing backend code. I just had like a JSON file that I would just make an asynchronous call for it. And also, I wanted it to be something that I have not done in the past. Until now, I've been working in projects mainly focused on kind of forms and configuring the application and just some informational pages, and also one project with Canvas. So this one, I wanted to be something that I have not done in the past, to learn something new. Something that will be also supporting some sort of media, like a video or music or some pictures, some kind of library maybe. And also something that would be appropriate for all of that 3 frameworks. Because if I would be writing an application, for example, with Canvas, I would use some Canvas specific library instead of Angular that it's not appropriate for that purpose. So I just wanted to make sure that it's an application that benefits from these frameworks. And the last 2 points is really that I didn't want it to be too simple, but at the same time, I didn't want it to be too time consuming, because if I was writing this application in my extra time, like between tasks or just during the weekend, I didn't want it to be like a burden for me. I wanted it to be something fun to write. And in that way, I would end up with a better looking application than if it would be something that I didn't like writing. So why did I choose Angular, React, and Vue? Mainly because they are so-called the big three frameworks right now. For the front end, they are the top popular and most downloaded JavaScript frameworks, which you'll be able to see in the next slide, some statistics. React is the most popular framework for UI since 2017. Before it was Angular. Right now, Angular is a bit behind. And also that's because React is, it just continues to win the service on the customer satisfaction. Which you can see in the last point, it's in case of React, it's 93%, in case of Vue, it's 90%, and Angular 2 is just 49%, which is far behind the other competitors. But also in case of Angular, you need to understand that it's still in development. Each 6 months, you get the new version of Angular. So they're trying to improve as they can when they go with the new versions. And also, it's interesting to see that Vue is growing faster than React, although it's still far behind Angular and React, but it's growing on Angular. So when Vue gets stronger, Angular gets weaker in the popularity. And then below, you also get the size of the gzip bundles for the framework. So Angular is the one that's the biggest one, almost 50 kilobytes. React in the middle, and Vue is the more lightweight of these frameworks. But it's also important to mention here that Angular just comes with a lot of features kind of out of the box, whereas Vue is just the minimal features that you need, and it doesn't really give you any more support. It just gives you the basic structure, and Angular just gives you, kind of brings more to the table. So this is the statistics that I was talking about. This is the node packages downloads per month. You can see that the one that's, it's from August 2017 till August 2018. You can see that at that point, React is the most popular one, although you can see that the difference that was, the difference that was between React and Angular in August 2017 was much bigger than right now in August 2018. But also you can notice that what I was talking about before, that Vue in this year has actually grown twice almost. You can see it was around here, and now in August 2018, it's 2 times the downloads it had a year ago, but it's still, as you can see, far behind React and Angular. So the requirements of the application, I wanted it to be as realistic as possible, to be able to kind of experience the same problems that I would have if I would write an application for the client. I wanted some scalable solutions that I could apply to all 3 frameworks, because my idea was that I would write the first application, and actually the first one was Vue, and then I could just copy many solutions from this framework to another application that was in the different framework. I didn't want to write each application from scratch each time, because it would just take too much time. So I wanted a solution that would be applicable in all cases. Then I was looking for separation of context. This is my personal preference. I like when the code and the logic is in a separate file, then a template in a separate file, and then styles also in a separate file. That's just my personal preference. I wanted to use Pure.js as much Vanilla.js as possible. So I just wanted to use TypeScript that's compiling to JavaScript directly. If you haven't used TypeScript, I recommend it. I think it's a great technology. And then on top of that, Angular, and also I was using Material Designs for the UI. So these were the only libraries that I would use. That's why I was trying to make it as pure JavaScript as possible. and then RxJS for all asynchronous operations. So I didn't use promises. Because you will see next in next slides that in the application I have a lot of dynamic elements. So observables are just the best for that. So that's what I was using. Again, I was using Material for the UI. Then I was using Webpack to compile each tree of the applications. In case of React and Vue, I was giving it my own setup. And in case of Angular, you use the CLI, and the CLI kind of takes care of the Webpack configuration. I wasn't using any stores. I was using just pure services because of two reasons. Firstly, because, as I was saying, I wanted scalable solutions. So if I would use, for example, NGRX with Angular or Redux with React, then I wouldn't be able to just copy easily my solutions to Angular, for example, because these implementations of Redux are a bit different. So that wouldn't be just so easy to copy, your actions from one application to another. So if I was using pure services, then I could just copy the file, and really it wouldn't change. I wouldn't have to change anything. And then I also wanted clean and efficient code, things like linter and alphabetical order, because that is important for me. And as I wanted scalable solutions, that's also part of when you copy code from one project to another. You don't want to copy dirty code and code that just doesn't look nice. So the solution to these requirements was a Spotify-like application that I would write in all three frameworks. An application that would have a similar user interface and interactions. So basically, you have all of the options that you have in a normal kind of music player, like playing a single song or a collection, looping a collection, shuffling the collection, putting the song forward and rewinding it, changing the volume, and saving some preferences about like the volume and so on. So that was really kind of incorporating what I was saying, that I wanted to write an application that would be new for me, and an application that would have some kind of media. So in this case, it would be music and also images for artisan album, kind of like a library. So that was really kind of fulfilling that point. And also I wanted a search and favorite functionality. I was also thinking about playlists, but at the end I just scratched that because I realized that it wouldn't really give any new difficulty to the project, because really a playlist, you can see favorites list like a playlist of your favorite songs. So at the end, I just resigned from that functionality. So this is how the application looks like. Of course, I will show you the living application. So on localhost 3000, I have the Angular one. Let's close that for a second. On 4000, I have the React one. And on 5000, I have the Vue application. You can see that they are slightly different as of UI, because Material is just a kind of like a standard written by UX designers, and then like Angular Material and React Material, they are kind of just the implementations of that standard. So they can have some small differences, but at the end you can see that they are pretty much the same. Just some sizings are different, but that's because of these different standards. So in the application, you can see the top header part. You have some dummy buttons here. They don't really do anything. You have the search input that I will show later. Go home button, and this just toggles the menu. Now you can see that the application is responsive. It responds to the changes of the container size. You get the menu with favorites and playlists. Again, playlist is just a dummy as well because I didn't implement that in the end. And in the homepage, you get something that's called personalized music for you. It's not really personalized. It's just random songs from the collection of the 10 songs that I prepared. So when you play a single song, I hope that won't be too loud, and that you'll be able to actually hear that I'm playing a song. Okay, so when you select a song, it of course plays it. It played 4 seconds of it. And below then it shows you the player. And when you click on next, it will just hide it. When you hover over the time line, it shows you at what point you have your mouse, and you can skip the song to that point. And when you hover out, then it will just bring it back to the state that it was before, so 4 seconds. The same with the volume, but it's also changing the icon of the volume as you change the volume. And here we have some more information about the song name, the artist, and you can put it to your favorites list. So the search functionality, I will search just for an A. So it will show me the artists that I have that contain the A letter and the albums. And below you can play all. So in that case, before I didn't have these buttons enabled because I just selected one song. But when you select play all, you can play a collection. Let me change the volume to like really. So now when I go next, when I play and I go next, you can see that now it's the second song that's selected, then the third one and the fourth one. When I want to play next, nothing happens because I'm not looping the collection right now. If I select loop, then now it will start from the beginning. And as I play next, it just goes forward. And here I also have the shuffle. So when I shuffle, it will also play like now the fourth one, third one, second one. Okay, show that again. First one, fourth one, second one, third one. So you can see that it shuffles these songs. And the favorites functionality. So I will add the Rockstar song to the playlist, to the favorites, I'm sorry. So now I go to favorites and it appears here. And if I, for example, click it from here, you can see it also added here because it's all done with the RxJS. So that's basically how the application works. So thank you. So going back to the presentation, some observations that I had when I was writing the application. So first of all, the separation of context is done differently in different frameworks. So on the left, you have how Angular does it. So you have your TypeScript file, HTML, and your SCSS file. So in the TypeScript one, you would define in your component decorator the template URL and the style URLs. You can see that they are the same as the files here. So that's how you divide your logic, template, and styles. In case of React, you don't actually get that. In React, what you do is to define your styles, usually at the top of your file, as a JavaScript object, actually. Then you would kind of import them. And then you have your component. And in the component, you have the special render function that holds your template. So in React, what you do is really you have your TypeScript X file, and you would just have everything in one file. In case of Vue, you have your Vue file. The Vue file is kind of like an XML where you specify your template. Inside of your template goes the template of the component, the script, and the style. You can write your script, like your component logic, inside of that script tag, but you can also add the source file. And in that way, you can have it divided into different files. The same with the style. And also when you add the scoped keyword attribute, this style will be only applied to this component and to nothing else. So to sum it up, in Angular, there is separation of context. You do have the scoped CSS. Anyways, when everything is compiled with Webpack, it's all converted to inline to just one file, really. And it's not forced, but it can be written in line. If you use Angular CLI, by default, it will generate you these separate files. But if you want to write everything in one file, you can do it just fine. With React, you don't really get any separation of context. And the scoped CSS is really with the style attribute. That's not really scoped CSS, but it kind of works like it. So With Vue, you do have a separation of context. Also, the scope CSS with the attribute that I was showing you is also converted all to just inline when you compile it. But in case of Vue, it's different as Angular. By default, they recommend to write everything in one file, but you do have the possibility to divide it into different files. So now change detection in these three frameworks. In case of Angular, it's really complicated. We could have another presentation of like 4 hours explaining how the change detection works with Angular. But basically, it's based on multiple factors. So we get the events like key down, click, and so on. So when that event happens, it's detecting the change. You get the XICHR, which are some asynchronous actions, and also timers like set timeout, at set interval. So what Angular does is it wraps this function inside of its own functions, and additionally to just calling the original set timeout, it will also trigger the change detection. And also what you have in Angular, you have the zones. These zones, they came from other programming languages and they were ported to JavaScript by the Angular team. And what the zones do is basically that you can run a code inside of a zone, and it can be even in asynchronous code. And you are able to tell when all of that code finished running. So in that way, Angular knows, when a specific function finishes, check if there was any change. And also you can trigger the update manually, calling detect changes. And you can set up your components in a way that they only listen for certain updates, because this kind of change detection is kind of expensive. So if you know that your component only updates in specific moments, what you could do is just say, don't listen to any changes. I will tell you specifically when to detect changes. In case of React, it's much simpler. You just call a special set state function. So because you call a special function that comes from React, that's how it knows when to how to detect the change. And you can also trigger the update manually, calling force update, although it shouldn't be really necessary in any case, because either way, you always change your state with set state. In the case of Vue, it's based on setters. I will show you in the next slide how it works. But that's why Vue needs the IE9 as a minimal requirement, because it needs these setters, and they were not present before. You also get the chance to trigger the change manually, calling next tick. And you can also improve your component with, when you know that a specific state won't change, you can freeze the object. And in that way, Vue doesn't use the setter anymore, and that state would never actually trigger a change. So in case of Angular, again, you have your template. You have let's say you have a click event. So when you click, that would trigger the change detection. In your function, you can have different subscribes. For example, here you have calling HTTP to get some asynchronous data from the server. And here you also have some name streams. So this is just some observable. So in both of these cases, when the subscription fires and what's inside finishes, and it knows when it finishes because of the zones, that's when the change is triggered. And here we also have the set timeout. As I was saying, it's wrapped inside of an Angular function. So it's not only calling a normal original set timeout function, it would also trigger the change detection after 5 seconds and when this assignment is finished. And so on click, it also was calling show name. So because of the zones, again, it knows when this function finishes, and that's when it's calling the change detection. In case of React, you can see much simpler. You just define your state at the top of your component. Here I'm subscribing to some favorites list change. When it happens, I'm getting songs from the server by ID. And when it happens, I'm calling set state. So that's how React knows, okay, now I have to run the render function again because they called set state, so it changed. So that's how it works. In case of Vue, actually Vue is my favorite one because it kind of, at the same time, it's very simple and very clever. So here on the right, we have just an outline of how it works. It's not how it really works, but just to give you an idea, when you define your state, so I would define a public property of songs, which is my state. So what Vue would do is to define a private properties like underscore songs. And then when you want to just receive these songs, so to like display them, it would just return the original object of underscore songs. But when you set the songs, so here again, I was subscribing to favorites change and I obtained the songs asynchronously and I'm assigning something. So this assignment would trigger this setter. And what this setter does is not only assigning to the underscore songs the new value that you are assigning here, but it would also mark the component for changes. So that's how it works. So now just some example of a simple problem that you usually get when you write a bit larger UI application. So imagine that you have this button that's toggling the menu. And imagine that this button needs to have the information if the menu is shown or not. So let's say that when the menu is collapsed, then the button is red or it's blue or whatever. So it needs the information if the menu is visible or not. And also the menu also needs the information about if it should be visible or not. So in that case, the holder of that information in a normal application would be app component that would have the isMenuOpen property, and it would just pass it forward to the nav drawer component that's the left menu, and the header toolbar that has the button. But then you can imagine a situation in which in the content you have like a set of different components like A, B, C, and D components, and each of them are like parents and children. So you can imagine that in that case, if app component is the one that's holding this information, you would have to pass it forward through four components, and they are not really interested in this information. So you're kind of making it to pass forward this information that's they don't really care about. This is actually, there are some paradigms out there that are using this kind of way. For example, the smart and dumb components. But the negative side of this approach is that if you have, for example, unit tests, and this small component, it just needs the information if isMenuOpen. It's not a big feature or anything. But if you want to add it, you don't just change one component. You have to change 5 components and their respective unit tests to make sure that the inputs, that the information is passed correctly, and so on. So this is something that I didn't want to have in my application. So a solution for that is, of course, having a service. So the service would be the holder of this information if isMenuOpen. And then the respective components, they would just subscribe to that information. And whenever a change happens, they would just know about it. Of course, there is also a negative side of this solution, is that these components, they are getting dependent on the service. So if you copy this component from this application, you want to put it in another application, you also need to copy the service because it's a dependency. But I like the way that these components, they don't care about that information, and so they don't really do anything about it. And then their logic just is simpler. So the singletons are objects, let's call them, that there's just one instance of them in your application. So Angular has that by default. It just supports it. So since Angular 6, you have that provide in root parameter that you can add to the injectable decorator. And in that way, you don't even have to import that service anywhere. And it's global, and it's just a one instance of this service. In the case of React and Vue, they don't really have services. So what I would do, I'm not sure if you can see it, but when I'm exporting from the file where I define my service, I'm exporting the const of this service. So in that way, even if I import it in like 100 different files, it's always importing just that object that I created here. So it's just creating one instance of that, because if I would have different instances of each menu open, of course, I cannot have that. So there can be just one instance, and it's created here with the node just calling const on it. And in that way, it's only creating it once, even if it's imported several times. So here's an example of how the music service works, and also how observables works a bit. So in your player view, you have the next button. And I defined in my template that when the user clicks on that button, it would call the play next function from the player component TypeScript file. So yeah, I'm waiting for this to disappear, but it doesn't. Anyway, so in the component, you have this. I'm defining that when the user clicks on the play next button, it would just trigger the music service play next from collection function. What this function would do is to check if there is a next song. If there is next song, it would play it. And apart from just playing it, it would also emit some new information, because I have information about the song, which is like the idea of the song, who's the artist, the album cover image, and so on. Then I also have the metadata, which is, for example, like the duration of the song, the extension of the file of the song, and so on. And also I'm emitting new time, because you can see here that I'm displaying the current time of the song. So I'm emitting all that new information, and in my player component, I'm subscribing to all of that different informations. And when that happens, Angular knows about it, because because of the zones, it knows when an update happens in the subscriptions. And that's what's triggering the change in the template. So I was saying that it's emitting a new song. So the song information we have, for example, here, like the album name and the artist name and so on. It's emitting new metadata, so it's I'm just using the duration of the song. So here you can see that the song is like 3 minutes, 30-something seconds. So I'm getting that from this subscription. And then the new current time, so that's why it's saying 1 second, because it just started playing the song. So now the in-depth analysis. What I focused on in this analysis was the compilation time, the bundle size and composition, the initialization time of the components, performance, and also the memory allocation. So I just show you some statistics to be able to compare all of these frameworks. So the compilation time, of course, it can change depending on the machine that you are compiling. When I was compiling and making these statistics, I was using an older Mac. So if I would run this on a newer computer, of course, it will take a shorter time, but by percentage, that wouldn't change. So the framework that was taking the longest time to compile was React. But you'll be able to see actually on the next slide that at the end, the bundle size is the smallest one. So even though it takes the longest time to compile, the end result was the smallest bundle. Then React, Angular in the middle, and Vue was the one that was compiling for the shortest time, just 13 seconds. It's because it's a small framework. It doesn't really do anything with the component. It's just JavaScript, so it doesn't do much things there. And also the hot reload. In the case of each framework, it would just take, just maximum 1 second to reload your application when you make a change once it's compiled and watching for the file. So in all cases, it was just working just fine. So the bundle size of the end application in kilobytes. React the smallest one, even though it took the longest time to compile. Angular is the biggest one, but again, just the framework is also the biggest one because it's giving you more features. And then Vue is not, it's closer to Angular than to React. So on the bundle composition, so when you compile with Webpack, you're able to see what your bundle consists of. So I'll show you, here I have the analyzed bundle for Angular, here for React, and here it's for Vue. So, so if you haven't seen before, that bundle analyzer is basically a representation of what your bundle consists of. So the bigger the rectangle is, the bigger is the size of this package. So for example, in case of React, I can see that just the material UI was 400 kilobytes. So that's kind of what you're able to see from the statistics. We are not able to see it more in depth because it's pretty complex. But what I just wanted to mention is that you can compare, for example, Vue with React, and you can see how different these bundles are. And it's also showing how differently written were these frameworks. Because in case of Vue, you just have like a big package where you just have to import the whole package and use it in the application. You are not able to just pick a part that you are interested in. In case of React, everything is written in a very kind of modular way. So you can see, for example, here the material UI. Each component is a separate module. So if you are just using like a drawer and a button, then it's just importing these modules, and it's not interested in any other modules that I didn't use in my application. In case of the Vue material, I had to import the whole package, and you can see that actually this is like the material, the Vue material is the one that took the biggest place in my Vue bundle. So what I would do probably would be not to use Vue material and maybe use a different UI package like Bootstrap. Maybe it's smaller for Vue, but because I wanted the application to look the same across all of the three frameworks, it stayed with Vue. But that's just the kind of things that you can see in that kind of bundle analyzer. So now I'll be talking about the component initialization time and performance. So the difference between them is that the way that I was measuring the initialization time would be to see when the component instance is created rather than waiting for it to be rendered. Because like in Angular, you have the ng-on-init function that's called when the component is initialized. But at that point of time, the component is not yet rendered. So it's not really usable to the user. So that's what performance is doing. In case of performance, I was looking at how fast it's rendered. But in case of initialization time, I would just see when it's instantiated. Both of these statistics are important because the initialization time, the faster that you have the instance of the component, the faster you can, for example, make a HTTP call, or the faster you can subscribe to some data, or the faster you can calculate something. So in a way, initialization time is as important as when it's rendered and usable to the user. So what I would do would be to type something in the search box. And so I would measure, since I typed the letter till I arrive to the search view, how much time would pass till, for example, ng-on-init in case of Angular, and React and Vue have their own kind of ng-on-init functions. So I would just check how fast it would take. And the obvious winner here would be Vue. That would take just 5 milliseconds to instantiate the object, when, for example, Angular just took 30 seconds. But what you should understand also from this is that really a difference of 25 milliseconds is not really noticeable to the human eye. So even though the difference is kind of significant, to the end user, really, that's not a very important statistic. Um, and what was also interesting to me is that I noticed that when I was instantiating the same component for the second time, it would take a much shorter time. So the first time I would go from home to search, it would take 31 seconds. But then if I would do this again without refreshing the page, it would be only 7 milliseconds. Sorry. So that was kind of interesting to me to see that it's probably doing some caching of the components. Then in case of displaying the favorites list, you have a very similar situation. Again, Vue instantiates first, and Angular and React are far behind. Then the performance, I would use the performance tool of the developer tools of Chrome. So it would just measure how long does it take for the application to be painted in the browser. You are able to see like millisecond by millisecond different steps of painting, like the images and text and so on. So in that case, React was rendering the homepage the fastest, but you can see that Angular wasn't that far behind. Vue was the one that was actually painting a bit shorter, but a bit longer time, but still it's not a very significant difference. In case of displaying the search results, it was just about 400 milliseconds. And again, Angular, the fastest one, but really the difference between the other ones, it's really not very significant, not to the end user really. So now the memory. So with the memory tool, you're able to see how much initial, the given application, how much initial memory it allocates at the beginning of the application, so when it's usable to the user. So the framework that would allocate the most memory was Angular, and the one that the fewest memory would be React. Vue being kind of closer to Angular, really. And then what I wanted to see is that how much memory it reallocates when you change your views. So what I would do would be to go then from home to search, then search something, then play all. So play the collection that I received in the search page. I would select an artist, I would add it to favorites, and then I would go to favorites. So after all of these steps, how much memory would it allocate comparing to the initial memory? So still Angular is the one that allocates the most memory, React having significantly less, and then Vue almost go to the level of Angular. But what's important in this statistic is that you can see here on the left the comparison of the initially allocated memory and then after doing all of these steps. And on the right, you can really just see the comparison of how much additional memory it allocated doing all of these steps. So you can see that even though Angular at the end allocated the most memory, but doing all of these steps, it actually allocated, just between these steps, it allocated the least amount of memory. So maybe after doing like 500 actions, Angular could be actually the one that would allocate the smallest amount of memory. So now to sum up everything, I created like a results map where I would just kind of throw all of different aspects of writing in these frameworks. So first of all, the bigger the size of the given property, the more important it is. And also, the properties that are more to the left, they are the more objective properties, and more to the right, they're more subjective. So for example, separation of context was just my personal preference, so that's why it's on the right. But compilation time is something that you can really measure and statistically show how much it takes. So that's how you can see the map. So you can see that the most important aspects were taken by React. The bundle size was the smallest one. the performance was the best. It was rendering the fastest. And then also the initial memory was the smallest one. Vue was kind of winning in the smaller objective properties. Like the documentation of Vue is really great. It's really complete, and it's really easy to use the framework thanks to that. The ease of use, it's pretty easy. And then it also has the separation of context. Where Angular is winning for me was in my subjective properties, so like separation of context. The code organization, what I mean by that is like in Angular you have modules, so you can divide your code into different modules, whereas with React and Vue you just have kind of loosely bounded components. And then you can see on the next slide, you can see the map of which frameworks did the worst in these categories. So in the most important ones, two of them are Vue, so memory reallocation and performance. And then the bundle size, the biggest one was Angular, and also the smaller important factors, also Angular. And in my subjective properties, React. What I mean by OOTB is out-of-the-box functionalities, so functionalities that come with the framework. So that's the result map. So to sum up everything, I was pretty surprised by how mediocre Angular results were. I was thinking that it would do better, but I noticed that the combination of the complexity of this framework and the difficulty of use, and also the very poor documentation that you have right now, it can be really like a deal breaker for many people. And I understand why the satisfaction surveys for Angular are just 50%, because it's really not easy to write with Angular. Then in case of Vue, I read a lot of articles about how good it is, how fast it is, and how good the performance of it is. But what I've seen in my statistic is that it didn't really kind of meet my high expectation that I had because of reading all of that articles. But I cannot say that overall it was negative. I can say that overall results for Vue were positive. I just was looking for something more probably. In case of React, it did best in the most important categories, as I was showing you. It failed on my personal criteria, but of course, as they are subjective, other person would just find it just the best framework for them for sure. But it was very nice to see that it allocated this memory. The bundle was the smallest, and that it was rendering the fastest. Also, React for me is the most transparent framework, and very easy to understand how it works, because in your render function, you just use JavaScript to kind of render your template. Like in Angular, you have to use like a special ng-for in your template, ng-if. The same in Vue, you have similar functions. So you have to not only know the component logic and how to write it, but also how to write the template. Whereas with React, you just use JavaScript to construct your template. So that's why it's just easier. But for me, Angular is also the most flexible structure-wise, because you are able to define your modules. You don't have to use like a special set state function or render function. You are the owner of your project, and you really can structure it really any way that you wanted to structure. And then the last 2 points are really just something that I kind of knew from the beginning. The title of the presentation is, last one standing. So kind of the idea was to find the best framework, but I really knew from the beginning that it's impossible to find one. And if it was possible, then probably we all would be using the same one. But it's just because there are too many factors. You could see that there are, the objective factors and then the subjective factors, but both of them are equally important, because I believe that if you like a framework, so it meets your subjective needs, like the separation of context, for example, then in the end, the application will be better because you will feel more comfortable writing it. So the more comfortable you feel writing the application, the outcome should be probably better. So the whole objective of writing all the 3 applications was really for me to compare these different frameworks, analyze how they work, and see how they differ, and then be able to see like in which situations they are more suitable for what kind of project they would be better. So that's it from me, guys. Do you have any questions?
What version of Angular did you use?
Angular 6, because I was writing it like 3 months ago, so there was no Angular 7 yet.
Rafa, could you repeat the question, please?
Will you please repeat the question just to for the remote people to know what was the question?
Oh yes, sorry. The question was which Angular version I was using when I was writing the application, and the answer is Angular 6, because I was writing that 3 months ago, more or less. So there was no Angular 7 yet.
Here is a question.
Thank you.
Are you measuring all the statistics that you show?
Okay, so the question was how I was measuring the different statistics that I was showing you. So to come back to the list, for the compilation time, I would just use like a command to have the current time and then compare it with the end time. Bundle size is really just showing, just looking at the file and how big it was. The bundle composition that was using the bundle analyzer plugin for Webpack. The component initialization time, what I would do would be, like for example, if I would go from home to favorites, then I would write like in my callback for the click, I would set the start time, and then when I arrive at my component in, for example, ng on init, I would then obtain the end time, and then I would just subtract from the end time the start time, and that's how I would have the initialization time. Then with performance, I would use the performance tool. I can show you here. If you open the DevTools, you have the performance tool. You are able to record your application, and then you can see millisecond by millisecond how it renders the application. And then in case of memory, I would use the memory tool. You can do the heap snapshot. So that would just kind of take the whole application and see and give you the size of it. So that's how I was comparing that. And also how I knew that it would, how much memory it reallocated would be to, again, do the heap snapshot after I did all of the actions.
I've got a question. So one of your criteria in your subject review was separation of concerns, style, JavaScript and template. And you argue that React is a weakness because it smashes everything together. But some people like pointing it out in the opposite way, as in every component is completely standalone in a single file. So if you make your application really detailed, as in little components, you get a complete separation of concerns. What's your take on that?
So the question was, the note was that there are people out there who prefer to have the logic and the template and the styles in the same file. And kind of what's my take on that? I understand that, and I understand why people would do that. It makes sense to have everything in just one file. Then you don't have so many files in your project and so on. But it's just my personal preference to have everything separate. I like when the logic is in one file and then the template in a separate file. That's just my personal preference, but maybe it just comes of the fact that Angular always did it that way. and I started with Angular. So you have your customs and the way you're writing from your first framework usually, and that's also why I think that kind of React failed for me in case of my subjective preferences, because it's much different to Angular than Vue is, for example. Vue is very similar to AngularJS, and that's why I didn't have a problem with Vue. But in case of React, it's just much different. So that's why I had some problems. But I can also imagine myself writing with Angular and having to cope with everything in one file. But if I would have a choice to have it in different files, I would prefer to.
Well, don't get me wrong, I do like that approach as well. I mean, React just takes me back to the nightmares of PHP.
Yeah, exactly.
I just can't get over that.
Yes, yes. So, yeah, for me also, I don't like when it's all mixed up, and it also looks for me like PHP and how it was kind of mixing everything together, and then you didn't know what's template and what's the logic anymore. But yeah, that's what you have with React. But I don't really see a different way that they could do it, because you have the render function, and you have your JavaScript there. So it kind of makes sense to have it in the same file. And then your styles, you are not really forced to have it in your file, because you can have just your styles separately. Compiled with some plugin, select all of the SCSS files from my project, put them all together, compile them. But then it wouldn't be a scoped CSS. You would just have to, have everything kind of as a global styles. So.
That component is for free, or do we need a budget in our project to use them?
Yeah, the question was if the applications are for free or if you have to pay. It's for free right now. So yes, and you can choose any application that you want. You can use Angular, you can use React, whichever you want. And also the repository, if you are interested in seeing all three applications, I can also send you a link to the repository if you want. So
thank you, guys.